All right. So the paper that you do have in front of you, we're going to hopefully get through the front side today, and then we will pick up the back side tomorrow. What we are looking at today are two new types of statistics that I don't think any of you guys have probably been introduced to before. Right now, when we talk about a group of numbers, I would say that you know four types of statistics, almost like what we would call like intro statistics. Yeah, I promise. One of them's the median, the mode, and the range. Okay. All right. So those four pieces, how do you find the mean of a set of numbers? You do what, Logan? Add them all together, divide by the total, right? That's how you find the mean or the average. Correct, by how many there are. What did I say? Oh, total number. Sorry. Yes, how many you had. All right. So the median, how do you find the median or what we would call the middle number? What do you do? Yeah. Okay, so you cross off big, little, but you better do what first? Put them in order from least to greatest, and then you can get into that. Okay. What is the mode? It is the number that occurs the most. Okay. So the number that occurs most often. And then the last one is the range. And the range is the max is the biggest minus the smallest is your range. Okay. So those are what we would like consider four basically like elementary statistics. Not meaning like elementary like oh second grader. Like no, elementary like kind of like beginning level. All right. So today we're going to bring in two new types of statistics. Get that word out. All right. The first one is what is called the mean absolute deviance, or what's abbreviated as MAD, M-A-D. You did it? Ooh, let's see what you remember. And the next one is what's called the standard deviation. You know what that is? Pay you $100 right now. Go. You are. All right. I like it. Okay, so we are going to get into some of that today. We'll definitely get through example one and example two. If we make it into standard deviation today, great. If not, basically your homework that you have in front of you will kind of break right here. Examples one and two would be stuff you could find on the front of your paper, and then example three and four would be what you would find on the back of your paper. Well, definitely not the whole thing, but if you want to tonight, you could do the first two parts. Or you'll say, nah, I'll just wait till tomorrow and do it all. Maybe some of it, like along the way, maybe. All right. So we're going to start though initially with this idea of what's called a statistic or a parameter. We'll let these go since we went through your entire homework. But can we identify a sample statistic? All right, and then a population parameter, and I'll define statistic and parameter for you in a second. And then analyzing the data, and we'll talk about how we do that as well. All right, so here's kind of what we're looking at. I pulled this giant definition at the bottom from your book because I know how much you guys love to read out of your book. Some of you guys probably haven't opened that thing a handful of times all year. All right, I don't need you to guilt yourself into how many times you haven't touched it. Oh, that's a good idea. All right. So that, that sounds rough. All right. So a sample statistic, all right, could be any measure that describes the characteristics of your sample. And that could be, right now, as far as we know, the mean, the median, the mode, the range. Those would be samples that we could use of statistics there. And then a population parameter is something that describes the characteristic of the population, meaning what's something that's going on with the overall population. All right. A parameter is basically like a border or an outline or limits of how far something can go. Okay. What's that? Okay. Like what? That's perimeter. So, yes, perimeter would be the distance around the outside. Well, you should have shared some of those cups of coffee with me. All right. So, that's okay. So parameters are fixed. All right, they determined by the entire population. All right, typically estimated on the statistics of a carefully chosen sample. Here's the important piece. A statistic can and usually is going to vary from sample to sample. Here's why. Every time we change the values, those statistical amounts change. The mean is going to be different in every problem because the numbers we start with are going to be different. Okay? The mode, the median, the range, those values are going to change as the numbers change. So when we talk about statistics, they're going to vary. Now, a parameter is not. A parameter represents the entire population, limits of the entire thing, of the entire sample. Okay? You're going to find that they're relatively consistent. Okay? As you look at your homework, you're going to see that the first three questions are asking for four things. They're asking for the sample, they're asking for the population, and then they're asking for this sample statistic and the population parameter. So we're going to do two of these together. I think you're going to kind of get the idea, especially considering we already really know how to do the first two because that's what our homework last night really covered. So looking at essentially the exact same screen, except instead of having that definition there, I've given you a problem and then these four characteristics. Okay. So a movie rental business selects a random sample of 50 orders in one day. The mean number of rentals per order is calculated. A movie rental business selects a random sample of 50 orders in one day. The mean number of rentals per order has been calculated. So the first question would be, what's the sample? The sample is the 50 orders. Okay. Those 50 orders that took place, that's our sample. Now, our population. Where did that sample of 50 come from? Yeah, I don't disagree. It's not as specific as what it should be. You have an idea? There you go. The rentals that came in that one day. Okay. If they pulled the sample of 50, where did they pull it from? They pulled it from what they did that day. Does that make sense? Now, a sample statistic is going to fall right off of line with your sample. So as you look at your homework, I put them side by side with each other. Like sample and sample statistic are side by side, and then population and the population parameter are side by side. The sample statistic. What was the statistic that was used in this problem? The what? The mean of what? Of the rentals. So the sample statistic is going to be the mean of the rentals in that sample. So essentially the mean of those 50 orders. That's the statistic that was used. Okay? Now, the population parameter is going to come from the population. So this one, any takers on what you think this one's going to be? It's a great place to keep your pencil. If I had curly hair, I'd do that too. All right, I'll show you this one. Okay. It is simply the mean number of rentals per order for all the rentals in that day. Okay. So the sample is 50, right? The sample statistic would be the mean of those 50. The population was all the rentals for that day. The population parameter is going to be the mean of all the rentals on that day. So sample and the statistic go together. The population and its parameter go together. What's up? Probably. Yeah, I don't see how it couldn't. You'd have to know what the heck your sample is. All right. So let's try it one more time. So here, a stratified random sample of 2 trees of each species is selected from all the trees at the nursery. The mean height of the trees in the sample is calculated. You know why they would do this at a nursery? No. What's the goal of a nursery? To sell plants, right? That's what they want to do. They want to sell plants. The bigger the trees are, The bigger the bucks, the more expensive they are, right? Because if people want new shrubs or they want, new trees at they don't want to plant a tree that's 12 inches tall and wait 15 years for it to grow. They want the tree to be, you know, 8 to 10 feet tall when they plant it. Like, you don't see people often buy plants, not like, and I'm not talking about like yeah, you're talking, something that's of substantial size. The they want them to be decent when they put them in. They don't want to wait 20 years for their shrubs to show up. You know what I mean? So the nursery, they do that portion. They get them small, they nurture them, they grow them, and then when they get to a decent size, now they start to sell them, and the bigger they get, the more they cost. So that when you put stuff in, it looks like it's already been there. You know what I mean? So here, they've taken a sample of 2 trees of every species, and then they're going to take the mean heights of all those. So what's my sample? Carly, what's my sample in this one? The 2 trees of every species. Okay, that's my sample. What's my population? All the trees at the nursery. Now, if I can answer those 2 questions, I should be able to answer the other 2. What is the sample statistic used here? The mean height, absolutely, of the trees in those samples, which would be the 2 of every one. And the population parameter would be the mean height of all the trees at the nursery. Okay. So basically, almost like what we're saying is like, where did that come from? Like, where is this information coming from in these 2? Well, it's coming from the sample and it's coming from the population. Yeah, from those 2 sentences. Okay. So you do have a couple questions where they're just simply trying to get you like to kind of get into the idea of being able to understand or identify how that comes. Okay. All right. So that's number 1. So here's number 2 on our list. This thing called mean absolute deviation. Now you said you talked about it last year. If I'd ask you to define it, yeah, that's typically how we do things, right? I mean, that's kind of our go-to. And we'll talk about this here, these 4 steps of how we find this in a minute. All right. And you can write that down, or you can get it from the video, or you can get this picture out of your book. But here's really what the mean absolute deviation is. Okay. It's a value that is going to tell me the average distance between each of my points and the average of the whole thing. All right. It's going to tell me the distance between the average of the whole set and each of my individual values. Here's why it's important. If you had a really good grade right now in class, okay, your average grade, it's good. But we got one more test coming up, and you do poorly on that one test. What happens to your average? It goes down, right? It drops, and how far it drops depends on how bad you do, right? Conversely, if your average right now is not good and you're telling yourself, hey, listen, we got a test next week, I'm about to knock it out. What's your hope? That you're going to bring that average up, right? And the problem with an average or a grade is sometimes we can't see the values behind it because we lump it into that one number. And so we don't really know if those numbers originally were all really closely related. Like you're 80%. Does that mean you had a whole bunch of grades close to 80? Or does that mean you had some grades that were really good and some grades that were really bad and they kind of just morphed into an 80? You know what I mean? Like, are you actually an 80% student? Or are you like a 95% student when things are good and a 50% student when things aren't good? Do you follow the difference on that statement? They both show that you have a grade of 80%, but do they both really reflect the same thing? And the answer would be no, they don't. Okay. And so this number that we're going to talk about finding, this mean absolute deviation, is going to tell us how close you actually are to that number. So a smaller number, a smaller mean absolute deviation implies that you're very consistent in what you do. Those numbers are all closely related. A higher value there really means that those numbers are really kind of fluctuating all over and they just happen to balance out here at this point. You follow me on that? Sort of, kind of? You'll see in this example, hopefully. All right. So here's the first one. All right. A rescue agency records the number of pets that they adopt each month. The question is, find and interpret the mean absolute deviation. Now, just looking at those numbers, they're all relatively close to each other. Would you agree with that? So I should expect that this mean absolute deviation should be low because my numbers are all relatively close. All right. So here's how you find it. Step number one, I need the mean or the average. Can you add those numbers up and give me the average? Do you know what it is? Say that a little louder. 16. What did you do to get that? So when you added them all up, you got 96. Okay. So really here in step one, I had 96 divided by 6. I get an average of 16, meaning like on average, they're bringing in 16 pets a month on average. Okay. Step number 2 says find the absolute value difference between every one of these answers and this answer. So essentially, how far away is my first answer from 16? It's 2 units away. How far is my next number away from the average? It's also 2 units. The next one is 4 units away. The next one is 1 away. The next one is also 1 away. And the last one is 4. Okay. So that is the difference between the average and all my actual numbers. What I'm going to do here is find the sum of these. So that means I'm going to add them all up. So add all these up. And I'm going to divide by the total. So in this case, I'm going to divide by 6. So add up 2, 2, 4, 1, 1, and 4 for a grand total of 14. So 14 divided by 6 is 2.3 repeated. Okay. So like we thought, or I thought, I guess originally, I could expect this number to be relatively low because these original numbers up here in my set were all close to 16. Okay, so you can kind of think of this like saying on average, each one of these values is about 2.3 units away from the total, from the average. Here's where I'd use it. If I was running this shelter and you came to me and said, hey, listen, on average, we're getting 16 pets a month. If I have only 20 open spots, am I okay? Well, my mean absolute deviation says I could expect this number to be off by 2 to 2.5 on any given time. So if I had 20 kennels available, would that be okay? It would be because on average, I might get as high as 18 or 19 and as low as, 13 or 14, and I could handle that. But if my mean absolute deviation was like 10, then what you're saying is we get months where we have big numbers and months when we have really small numbers. And even though they averaged out to be 16, if I don't have enough kennels to cover that, I would be in trouble there. Because my average says it would happen, but this number says there's going to be times where you can't do it. Does that make sense? What's up? Say that again. Because I thought you were going somewhere else and then you didn't, and then I lost you. Give it to me one more time. Uh huh. Sure, relatively speaking, like what is it that I'm talking about? Absolutely, yeah. So here we're talking like 2 to 2.5 pets, which would be way different than, like a temperature of 2 degrees. Like a difference of 2 degrees isn't going to make a big deal. If I got to find a place for 2 or 3 more pets every month, that's different. Absolutely. That's a great question. Absolutely. All right. Let's try it with this one here. Get all that on there at the same time. So a statistician reviewed the number of points his high school team gave up at their home games. So how many points they allowed. and they played 6 home games. So they gave up 14, then they shut them out, then they gave up 20, then they gave up 24, then they gave up 17, and then they gave up 30. These boys is all over the map. Okay. Now, just looking at those numbers, what could you expect to happen with your mean absolute deviation? It's going to be higher because these numbers, they've got bigger change going on to them. Okay. Andrew, you all right back there? Yeah. So step number 1, I need the average. Add them all up. What do you get for an average? What do you get? 105. And 105 divided by 6. So 105 divided by 6 is an answer of, okay. So on average, they're giving up 17 and a half points per game. Points per game, PPG. Their mean absolute deviation is found by looking at each of those individual numbers in relation to this average. How far away? How far is the first one away? 3.5. So we're going to keep track of these. So 3.5. Now remember, we're going to add all these together. So 3.5, that's the difference of the first one. How far is the second one off? The whole thing, right? They pitched the shutout, so that's 17 and a half away from the average. It's like what happens when you guys take a 0 on something because you don't do it, or if heaven forbid you got caught cheating or something like that, and you take a 0, like it really kills your average because you got to put that in there. Like I'm not going to divide this thing by 5. There are 6 scores here, right? So the next one is going to go in as well. All right, so my average is 17 and a half. How far away from 20? It is, Bella, 2.5. The next one is 24. So how far away is that from 17 and a half? 6.5. Yep. And then the next one, they gave up 17. That's almost right on the average. That's only off by 0.5. And then lastly, 12.5. That's how far it was away from 30. Okay. So 3.5, 17.5, 2.5, 6.5, 1/2, and 12.5. Those are all my numbers. That's how far away I was from each one. Add all those up. What do you get a grand total of? Better be some whole number because each one of them's got a half on them. 43. So it's going to be 43 divided by what? 6. So what's 43 divided by 6? 7.16 repeated. So let's call that 7.2. So that is my mean absolute deviation, or what's abbreviated as MAD. All right. Meaning every one of my scores on average is how far away from 17 and a half? 7.2. So essentially in this case, almost like a touchdown away, right? Okay. Now, based off of that information, which one of these 4 choices is the correct choice? A, B, C, or D? I think you guys could even use Mr. Tosh's testing strategy that he gave you guys. Do you remember that? The multiple choice testing strategy he gave you? Any takers on which one you think it is? Kyler, what do you think? Okay. You agree with him? I think. Is that what you're saying? Show me. Okay. What do you think it is? You agree? Jack, you agree or disagree? You agree? It definitely can't be A. The team didn't give up an average of 7.2. We already found the average, 17 and a half. Okay. D could be right. On average, the team gave up 17 and a half, but we were asked to find the mean absolute deviation, and it doesn't speak of it. So it's got to be B or C. And in this case, oh, that's nice. In this case, maybe. There you go. It is C. All right. We would not say that this is affected by the outliers of 24 and 30. Those aren't outliers. They gave up 24, they gave up 30, they gave up 20, they gave up 17. This team gives up points. Maybe in week 2 there, they were playing like Our Lady of the Blind, and that's why they didn't give up any points. Something like that's, if you want to talk an outlier, the fact that they gave the shutout, that's the outlier, not the fact they were giving up points. They've done that in every game. All right. So We're going to go ahead and put the brakes on there because we got about 5 minutes to the bell's going to ring. You, at this point, though, can answer anything on the front of that paper. Okay? You cannot yet answer the questions on the back, and that's okay. We'll talk about standard deviation tomorrow. All right?